This is a work that we have started doing together with my PhD student Salam Al-Obaidi and the master student Shashank Gupta, who is just going to graduate in a couple of weeks at Department of Civil and Environmental Engineering in Polytechnic di Milano, trying to use data mining strategies and then artificial neural network also in order to develop some predictive capability model for self-healing capacity of cement-based materials. Well, actually, Emilio, one of the previous speakers, cited Plato, the myth of the cave. And I went a little bit into my Latin background. Intelligence actually comes from the Latin intus legere, which means reading inside. So what we have tried to do is trying to read inside the huge amount of literature which exists on self-healing concrete. And you have there a classical table of content for this presentation. So what about self-healing concrete? Autogenous healing of concrete is a natural process which leads to the partial or total closure of the cracks without any intervention by the human. And this can also result surely into improved durability because you close the ingress path for the aggressive agents into a concrete structures. But in some cases, and for some specific categories of advanced cement-based materials, can also result into partial regain of mechanical properties, which can be useful for a long-term structural design predictive performance of the structure. Well, this is a classical picture in self-healing literature. It can be due basically to chemical processes, which are the continued hydration of unhydrated binder particles or the calcium carbonate precipitation, this depending on several variables, which is the mix design, the age of concrete when the crack appears, and so on. And these are the true irreversible causes of self-healing. Then you can have a physical mechanism of swelling, which is surely reversible, because when the moisture decreases, you have back to the original size. And some mechanical properties, if there are debris in the water of particles which detract from as well, they can clog the crack. As a matter of fact, nowadays there are different technologies to stimulate or to enhance or to engineer this healing, which can be the use of supplementary cementitious materials, which can be the use of stimulating crystalline admixtures, the synergy with fibers or other technologies. And if you make a simple search into Scopus, we use that self-healing concrete as a key of research. You can see that the literature being published in the last 10 years or so has been dramatically increasing, and the topics in which this paper fell is truly becoming interdisciplinary. But as a matter of fact, we have to say that it has really very widely investigated. The parameters affecting self-healing have been investigated mostly from the qualitative point of view and less from the quantitative point of view. And this leads to a current gap also in engineering design approaches, which is the lack of methodologies in order to take into account and exploit the benefits of self-healing into a durability-based design for reinforced concrete structure, which is what the industry may ask for. If I have to pay something for a self-healing technology, I want to understand how can I take this benefit into account in a design perspective, in a life cycle perspective, and so on. So this was the main motivation which led us to do this study. And we performed first a meta-analysis and then trying to develop through also artificial neural network some predictive design cards. Well, we first of all made a literature search in order to build a database. Actually, we were able to keep as valid only 100 peer-reviewed journal papers because there was the need of knowing a certain type and amount of information related, for example, to the mix design, the dosage of cement or of supplementary cementitious materials, or of healing stimulating admixtures, fiber content, if any, water cement ratio, crack width, age of cracking, duration of the healing, type of curing environment, and so on. And as output parameters, we try to quantify the recovery of a performance, which could be surely the crack closure, but not in all papers you can find it, or the recovery of a performance from the durability point of view, which could be the permeability or a physical property like the ultrasonic pulse velocity or electrical resistivity or impedance, also related to some kind of chloride penetration, or mechanical strength recovery. And we processed the data which could find in the database through the definition of some self-healing indices, which you can see in the very simple formula in the last column. Basically, if that index is 0, it means that you have no healing. And if that index is 1, it means that you have perfect crack closure or full recovery of the performance that you are considering. So we first made some, we built some forest plots, just a few information. Well, we have this diamond shape final information in which we have the magnitude of the effect that we are considering and the margin of error, which represents the side of the diamond. And well, actually the actual numerical value depends on how the question is posed. So in this case, for example, for the crack size, the least negative value meant that the self-healing performance was better. So in this case, you see that for crack size below 75 microns, you have a Cohen value of minus 0.205, which is the lowest one. And obviously, as expected, it means that narrower cracks heal better. But this was, for us, also a check on the reliability of the algorithm and the tools that we were developing. Well, we went also in the period of healing, and in this case, obviously, we obtained that the least positive, depending on how the question was posed, value was better. A longer healing period favors the closure of the crack. Well, we were surprised here because we detected from our analysis that, for example, the addition of mineral admixture or supplementary cementitious materials have not the effect that we expected, in the sense that it's probably the least sensitive parameter. Whereas if you use some kind of chemical stimulating admixture, we have a good effect on the self-healing. And finally, obviously, the healing condition, here on the left, on the negative side, you have in favor of permanent immersion in water or in a highly humid environment, and on the right side for positive values you have wet and dry or humid dry cycles, which are less favorable to healing. And here is a summary of which is the most favorable effect, whether you did consider the magnitude of the event, which is the healing condition, or whether you do consider the confidence ranking, and the modulus of error, in this case, is the period of healing. So summarizing the results, also we went into this relatively important analysis where we found that these are the main parameters affecting the healing. Obviously, the most important one are the total amount of binder, which can react upon time, and the crack width. And then you have age of healing. Water cement ratio also has an effect, because if it's low, you leave the material hydrated and available for further reaction. And fibers has least effect. So then we try to develop these predictive design cards in the end. For example, here is an example of the work. This is still a work in progress. Crack width versus duration of healing. You can see that for narrower widths, a shorter healing is enough to achieve a very important self-healing indices, the ISO self-healing lines you can see there. Whereas if you go for wider cracks, you need a longer healing period. So this is what expectable. An interesting thing, and this still we are working on, this design card, which compares the effect of WC ratio, water cement ratio, versus the content of cement. Well, this is an example on also how the typical mix or composition of cementitious composites can affect the database, because actually, if you have mixes with higher cement content, these are typically high performance or ultra high performance concrete, which generally have very low water binder ratios, which are favorable to healing. Whereas if you go for low water binder ratio, or lower cement content, you likely also have high water cement ratios, which means that you have a poor concrete. So in this case, we have to reflect a little bit more on the quality of the data and on the nature of the data as they are affected by the concrete technology. So then we went, this is a work that we are still performing, into building, validating, training, and testing artificial neural network. We ended up with an optimal number of neurons of 18. We worked with one layer so far, so we calibrated the activation function, the adaptation learning function, and so on. And you can see some example of the plots, and also a comparison between the Delaunay triangulation of the database and the artificial neural network prediction, which relates crack width versus cement content for similar values of the self-healing index. So you can see that a wider crack widths for higher content of cements can have a comparably higher healing ratio and crack closure ratio. So just coming to the conclusions, we have used data mining strategy, meta-analysis, and artificial neural networks to process and interpret a huge amount of literature on self-healing. Obviously, some of the conclusions that we have got from the quantitative point of view were as expected, in the sense that the crack size, the duration of healing are the most important variables and the most favorable for the self-healing process. Narrower cracks are better healed, longer period is more favorable. The mineral admixture content or supplementary cementitious material content had the lower effect than one we expected. So what we are aiming to is, it's a little bit ambitious sentence, extract knowledge from data, but this is really what we need to go through in order to really exploit the huge amount of literature which has been published on this topic, because we want to pave the way towards the definition of scenario-based healable crack width concept, because this is something which can really enter into a structural design code, because the crack width is a parameter that structural engineers are really used to, is a parameter which currently enters the durability prescription for reinforced concrete structure. So it's something that you can use also to exploit the benefits of self-healing in structural design. You cited in the introduction this European Commission funded research project in whose framework this work was performed. So I acknowledge surely the funding of this project. And I also thank all my research group. You can see us here 1 year ago, smiling in front of the main building and Polytechnic and observing social distancing and personal protection devices just a couple of weeks ago in a almost early spring here in Milano. And thank you very much for your attention.